So I have this little ball which moves for a very short time, and I have found the change in velocity from this triangle. I found this change in velocity, and therefore I can divide by the time to get acceleration and multiply by mass to get the force. So let me do this. Let me complete this calculation. Now first I need to clear some space. So let me start by finding the acceleration. Acceleration A, that will be change in velocity over time, and since this is the change in velocity, at 0.0045, I've called my change in velocity W in this case, so it's W over, okay, never mind the W, I'm just going to go straight to the number 0.0045 divided by the time, which is 0.001 of a second. So that gives me 4.5 meters per second squared, and that would be in this direction, okay, towards the center of the circle. And finally, to find the force, I must multiply mass by acceleration. Mass is 0.2 kg, 0.2 kg. Acceleration I've just found to be 4.5, and therefore the answer is 0.9. Alright, 0.9 Newton, and there we have our answer. So we find all this using the definition of acceleration, using the Newton's second law, using the way of subtracting vectors to find the change in velocity, as well as some knowledge of finding arc length, relating arc length to the angle of a circle. Now, what I like to do next is to obtain a formula, right, from what we have understood so far, to obtain a formula for this acceleration and force, so that next time we don't have to go through this long process of working through every step in order to get the answer. So I can have a formula that I can use directly. Now, in order to obtain this formula, let me retrace the steps. Okay. I want to relate all these numbers directly to the starting quantities that I know, or at least to quantities that I would normally expect for circular motion, like in this case maybe angle, time, velocity, okay, mass, and perhaps there's another quantity that we would need to use, which is omega, the angular velocity, which is angular displacement divided by the time. Okay, so we can make use of this as well. Right, so let's one thing though, let me, just to avoid confusion, let me point out the difference between this symbol, which is called omega. Omega is a Greek letter for omega, for O probably, and that letter here, this is W. Okay, you see, W has bottoms that are sharp corners, whereas omega has bottoms that are rounded. So these two are different symbols. So hopefully we don't get confused along the way. Okay, so let me start by trying to obtain an expression for the acceleration. Now, the acceleration came from the change in velocity over the time. So, okay, let me try and write this out. Acceleration is equal to change in velocity was W over time. So W with the sharp corner, okay, that's W over time. Now W, as I've calculated here, as I've found here, so is very nearly equal to velocity times this small angle, because of how this because of this triangle, because this length here, this length of W is very close to the arc of a circle centered at this point, since the angle is very small. So W is very nearly equal to V theta, to velocity times the angle over time. So we already know all that. Now I'm going to make use of this relation between angle, time, and the angular velocity, because angular velocity for uniform motion would just remain the same, whereas angle and time can keep changing. Okay, so it might be easier if I just express in terms, if I can express in terms of the angular velocity. Now you notice that this is theta over t, that's also theta over t, which is omega. So therefore, I can replace this by omega. So that's v times omega, v times the angular velocity. So now I actually have a formula for the acceleration. Okay, if I know the starting velocity, the speed of the ball around the circle, and I know the angular velocity, I can just multiply the I would call this the linear velocity, right? The linear velocity by the angular velocity, and that gives me the acceleration. So that's quite simple. I don't actually have to draw all these triangles and think about all the change in velocities and approximations and so on and so on. Just a simple multiplication of v and omega. Okay, and if I look at the force, force is mass times acceleration. So therefore, if I just take F equals to ma, mass times acceleration, mass, and acceleration is v omega, so ma is equal to m times v omega. Again, a rounded omega, that's not w, that's the angular velocity. So now I have the formula for the acceleration and for the force. Right, acceleration is just mass, force is just mass times acceleration. So that's the main thing to remember.